today we're going to divide polynomials, right? So we've been working with polynomials for several classes now. Today we're going to learn how to divide them. And the method we're going to use is very similar to long division of whole numbers. So we have to make sure that we can remember how to do this. All right, so what's the first thing I do? Yeah. Yeah, so first you ask yourself about the first number. And you go, how many times does 11 go into 7? It doesn't. So you go one more place to the right. How many times does 11 go into 78? 7 times. And then you do 7 times 11 and you get 77 and you subtract. 78 minus 77 is 1. Bring down the 7, right? And then how many times does 11 go into 17? 1 time. 1 times 11 is 11 and you subtract. You get 6. There's nothing left to bring down. I could put a decimal point 0 there if I wanted to do this as a decimal, or I could take my remainder and express it as a fraction. So you could do 6 over 11. So 71 and 6/11 is the answer. Okay. Number 2, rewrite in descending powers of x. That just means put the term with the largest x power first. So we're going to have 6x cubed. And then the next term is going to be minus x squared. And then minus 5x plus 4. All right, and then this last one, I was just gave several different people. I changed it to numbers, right? If I write 35 divided by 7 equals 5. Somebody use those same 3 numbers to write a multiplication sentence. 5 times 7 equals 35, right? So your dividend, which is the thing on top, divided by your divisor equals your quotient. I know, yeah. So you can multiply your divisor times your quotient to get your dividend back. So if I want to factor that cubic, I can just multiply the x minus 3 times the 2x squared plus 3x minus 2. Nope, that's it. Just quotient. Q-U-O-T-I-E-N-T. Okay, so dividing two polynomials, division of two polynomials can be done using an algorithm that's very similar to division of regular old numbers. We're going to start by looking at the long division problem from the preview exercises, but I'm writing it a little bit differently. So the 11 I'm writing as a 10 plus a 1. The 700 part of 787 I'm writing as 700, right? 787 I'm writing literally as 700 plus 80 plus 7. Okay, so the way we've made this work, first we said how many times does 10 go into 700? 70 times. Yep. And then we take the 70 times the 10 and we get 700, and 70 times the 1 and we get 70, and we subtract. Maybe I'm doing this wrong. I get 10. No, this is right. I get 10 and I bring down the 7. Yep. So it looks a little different, but it's basically the same algorithm. I'm lining up place values. So but you have to get back to that 1, right? That's the idea. So yeah. Yes. Yeah. So that's what you did when you went 11 into 78. You really are looking at the tens place, and you first ask yourself how many times. Hey, can you stop talking, please? Thank you. You ask yourself how many times does 10 go into the 700? That was the first thing. All right. So then the 70 times the 10 gives you 700. 70 times the 1, because really before we had to do 7 times 11, right? But it's so 7 times the 1 gives you 70, and then you subtract. So how many times does 10 go into 10? Once. 1 time. All right, so 1 times 10 is 10. 1 times 1 is 1, and you subtract and you get 6. So it came out the same. 70 plus 1 is 71, and we still have 6/11ths. All right, that's confusing. Yeah. It is subtraction. So it's subtracting this whole thing. So sometimes it might be helpful if you put parentheses like that. So you have to do 10 minus 10, that gives you 0. And then you do 7 minus 1, that gives you the 6. It's the same answer as before. 71 and 6/11ths. Yeah. Arrows where?
First, you multiply the 70 by the 10, and it creates 700, and then you multiply the 70 by the 1, and it creates 70.
Like that?
Yeah.
So that's where they got 700, then the 70 times the 1, that's where we got the 70. And then when we did the 1, multiply the 1 times the 10, you get 10. Then multiply the 1 times the 1, and you get 1. Yeah. Good. All right. So it's going to be similar when we do polynomials, but this time we're going to replace the x that we had over here. We had a 10. I'm going to replace all the 10s with x's. So 10 plus 1 would be x plus 1, right? How would I write 700? If x equals 10, how would I write 700? Close. You're almost there. 100 is how many tens? Okay, that's true. 700 is 70 tens. What's x squared? 100. So 700 is 7x squared. All right, and then 80, that's 8 x's. And 7 is just 7. So x is going to represent 10. So 700 is 7x squared. 80 is 8x. We're making a polynomial. And the division is going to work just like it did when the important number was 10, but now the important thing is x. All right, so here's how it works. First, you look at just the x and just the 7x squared, the leading term of each polynomial, your dividend and your divisor. All right, how many times does x go into 7x squared? Or stated another way, what do I multiply x by to make 7x squared? 7x. So I'm going to put a 7x right here. And then I have to distribute that 7x to the x and the plus 1, right? So the arrows here. 7x to the x, 7x to the 1. 7x times x is 7x squared. 7x times 1 is 7x. And then we subtract, right? 7x squared minus 7x squared is 0. Those go away. 8x minus 7x is x. Bring down the 7. Okay, then we start again. Then you go back to your divisor, x plus 1, and we want to say, okay, how many times does x from the divisor go into x from x plus 7? 1 time. So I'm going to write plus 1 up here. And then I have to distribute that plus 1 to the x and to the 1. Right? So 1 times x is x. 1 times 1 is 1, and I subtract. X minus x is 0. 7 minus 1 is 6. No, 6 is the remainder, so it's not a factor. So what this says, as a summary, right? This says that x plus 1 is equal to 7x plus 1 plus 6 over x plus 1, right? You take your remainder and put it over the divisor. All right, so we should check. Let's check with our division algorithm. We always have to make sure that the divisor times the quotient plus the remainder equals the dividend. So we got to remember all the vocabulary from long division. Divisor is the thing you're dividing by. So up here it was in the 10, it was 10 plus 1, which is 11, right? The quotient is the answer, right? 71. Plus the remainder 6. That should give me the 787 under the bracket. So 71 times 11 is 781 plus 6 is 787. Check. Okay, now when I do it with polynomials, my divisor was x plus 1. My quotient is 7x plus 1. My remainder is 6. If I multiply the x plus 1 times the 7x plus 1, just FOIL it out, you get 7x squared plus 8x plus 1, and you still have this plus 6. So that's 7x squared plus 8x plus 7, which was our original dividend. Check. Right. Yeah, I know it feels really weird, like you never actually write all this out with numbers. Yeah. Good, good. Okay, one more together. And then hopefully you'll have it down and you can practice some division on your own. Okay, 6x squared plus 5x plus 6, divided by 2x plus 3. The first step, arrange the terms of the dividend and the divisor in descending powers of x. That's already done. Okay, so all set. Step 2 is to divide, right? So I'm not even going to read through these steps because we're just going to do it on the board together. So I want to do 6x squared plus 5x minus 6 divided by 2x plus 3. So first, you ask yourself, just look at the leading term of the dividend and the divisor, and you say, what do I multiply 2x by to make 6x squared? 3x. So I put a 3x up here. Then I multiply. 3x times 2x is 6x squared, and 3x times 3 is 9x, right? I'm distributing this. And then I subtract. 6x squared minus 6x squared is 0. Those go away. What's 5x minus 9x? Negative 4x. Bring down the negative 6. And then we start again. What do you multiply 2x by to make negative 4x? Negative 2. Negative 2, then I distribute that negative 2 to the 2x plus 3 when you multiply. Negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6. And I subtract. Negative 4x minus negative 4x, 0. Yep. Negative 6 minus negative 6, 0. Okay, so my remainder here is 0. And that means that I can write 6x squared plus 5x minus 6. It can be factored 2x plus 3 times 3x minus 2. Right? If it goes in evenly, that tells me that 2x plus 3 was a factor, and the other factor is 3x minus 2. And we should check. If we actually FOIL out that thing on the bottom, 2x plus 3 times 3x minus 2, we get 6x squared minus 4x plus 9x minus 6. And that does give me 6x squared plus 5x minus 6. So you can always check. People still writing down stuff? Okay, good. All right, so polynomial long division is checked by multiplying the divisor with the quotient and adding the remainder. Okay. So maybe I'll write out dividend is f of x. That's the thing under here. Dividend. Or maybe I'll just use words to help you keep this straight. Dividend is what goes under the bracket thing. And then the number you divide by, or the expression you divide by, is called the divisor. What you get up here is the quotient. And then you do a whole bunch of work, right? And down here you get the remainder. Right? And this says that if you multiply the divisor times the quotient and add the remainder, you'll always get back to the dividend. Okay, that's how you can check your division. Is this still demo? Okay. All right. So here we have a polynomial function f. It's got zeros at -2, 1, and 3. So you can see them. They show up on the graph as x-intercepts. They all have multiplicity 1. How can I tell that by looking at the graph? It passes through the axis in a almost like a straight line. So those are multiplicity 1. Okay. So if I have zeros, then what do the factors have to be? If x equals -2 is a 0, what has to be a factor? Close? No. All right, let's remember when you're trying to find 0. So here's my formula. I don't know what the factors are, but this thing has what's the end behavior of this graph makes us think the degree of this polynomial is what? Odd. Yeah, right arm up, left arm down, odd. And how many turning points does this have? 2. So what's the smallest degree it could have? 3. So it's got 3 zeros, right? Which also indicates degree 3. Okay. So that means that I should be able to write it, if it's degree 3, I should be able to write it as the product of 3 factors. Okay. And when you're trying to find the zeros of a function, remember you take the factors and you set them equal to 0. Right? You set the function equal to 0, and that means you set each factor equal to 0. All right, so let's look at this first factor here. If the answer is x equals -2, what did the factor have to be so that when I solve this equation, I get x equals -2? Plus 2, x plus 2, right? Because then you would subtract 2 from both sides, and you get x equals -2. All right, what does my factor have to be in order to get x equals 1 as a 0? No. Minus 1. X minus 1, right? And then you'd add 1 to both sides, and you get x equals 1. And then my last 0 is at 3, x equals 3, which means this had to be x minus 3. Right? So those are the factors of my polynomial, x plus 1. Oh, sorry, that was x plus 2. X plus 2, x minus 1, and x minus 3. All right. So if x plus 2 is a factor, then we know x equals -2 is a 0. So f of what would give me 0? -2. That's what it means to be a 0. If you plug in the number, you get 0 as the output. Okay, if x minus 1 is a factor, f of what would give me 0? 1. And if x minus 3 is a factor, then f of 3 is 0. And vice versa. If f of -2 is a 0, then you know that x plus 2 has to be a factor. And if f of 1 is 0, then x minus 1 is a factor. If f of 3 is 0, then x minus 3 is a factor. -2, yeah. So the summary of our findings here is that if f of x is a polynomial, if you know a 0, then you know an associated factor. If you know a factor, then you know an associated 0, right? If you know c is a 0, right, because f of c equals 0, then you know x minus c is a factor. If you know x minus c is a factor, then you know f of c equals 0. You know one thing, you know two things automatically. Okay, so I want to use the factor theorem, which is what we just talked about, to factor, to solve this equation, 2x cubed minus 3x squared minus 11x plus 6 equals 0, given that we know -2 is a 0. Okay. So here I put up a couple of bullets that are going to walk us through it. So since -2 is a 0, then by the factor theorem, f of -2 equals what? 0. Yeah, that's what it means to be a 0. Yep. So if -2 is a 0, then what's a factor? X plus 2. Yeah. Yep. X plus 2 is a factor. So then we'll use that factor together with long division to find another factor. Okay, so I'm going to take my 2x cubed minus 3x squared minus 11x plus 6 and divide by x plus 2. Now what we're doing right now is called long division. In your homework, they won't tell you what kind of division to use, but you'll have to use some kind of division. This is the one I'm teaching you. If you choose like help me solve this or see an example, they're going to do a different kind of division called synthetic division. You can just ignore it. They don't do this kind of division.
Would you rather we learn this instead?
Yeah, I think that this is better. Yeah, yeah. Okay, so the way we go, let's go through this algorithm one more time. First, ask yourself, what do you multiply x by to get 2x cubed? 2x squared. And then you distribute that 2x squared to the entire divisor x plus 2. 2x squared times x is 2x cubed. 2x squared times 2 is 4x squared. And I subtract. 2x cubed minus 2x cubed is 0. Those go away. And then I have negative 3x squared minus 4x squared, which is, yeah, negative 7x squared. Bring down the minus 11x. What do you multiply x by to make negative 7x squared? Negative 7x. Then we take that negative 7x squared and we multiply it by x plus 2. Negative 7x times x is negative 7x squared. Negative 7x times 2 is negative 14x. Subtract. Negative 7x squared minus negative 7x squared, those drop out. And then we you have to be a little careful with the signs here. Negative 11x minus negative 14x. 3x, yeah, so it's actually negative 11x plus because we have minus a negative. It's actually plus. So that becomes 3x, and we bring down the plus 6. And then what do you multiply x by to make 3x? 3. 3 times x is 3x. 3 times 2 is 6. Subtract, and the remainder is 0. So what they had asked us to find was another factor, right? Or the other factors. So I know x plus 2 is a factor. Now I know that if I multiply x plus 2 times that quadratic, I should get the 2x cubed back. Yep, I should get the 2x cubed back. Can 2x squared minus 7x plus 3 factor any further? Yep. So let's write this all out. I'll do a new page here. It depends on the directions. Yeah. Yep. I'm going to now just to It didn't explicitly say to, but I think just for demonstration purposes. All right, 2x cubed minus 3x squared. I think it was plus 11x minus 11x plus 6. Okay. And we knew x plus 2 was a factor because they gave us a 0. And when we divided, we got 2x squared. What else? Plus 3. Okay. And then I could try to factor that quadratic a little bit more. So let's see, 2x and x, and maybe minus 3 minus 1. That gives me 2x squared minus 6x minus x, which is negative 7x plus 3. Yeah. So there, I've now written it as 3 linear factors, the product of 3 linear factors. And you could check by multiplying it all out. Make sure that you get 2x cubed minus 3x squared minus 11x plus 6. Okay, now it's time for you to try doing some division on your own.